Hey everyone, AMR back again with another Python video. So my video yesterday ended up getting quite a bit of attention. I think that was probably largely due to a lot of interest on the channel. So I think what I'm going to do is I'm going to go to LeetCode. So for those that don't know, LeetCode is defined here as LeetCode.com, where if you are preparing for a technical interview or really just wanting to challenge yourself, especially if you're learning this stuff in school, LeetCode is going to be your go-to. So every single Saturday, I want to say at like 10 p.m. Central Time, they have like a coding competition or whatever. You basically just compete for like LeetCode.com credits where you can unlock certain abilities and stuff. It's just like similar to any other thing that you do whenever you sign up for something. But yeah, like as you can see, like look, it's every Sunday, 2:30 to 4 a.m. UTC. So I'm guessing that's Saturday at 10:30 p.m. like I said. And then you also have the bi-weekly contest. I actually don't know what UTC, I know what UTC is, but I don't know what 2:30 UTC is. I think it's minus 6 hours, which is what, that'd be 8:30 p.m. 8:30 p.m. on Saturday night is this one, and then 8:30 p.m. on Friday will be the bi-weekly one. But anyway, that's all for another day. I think I'd just be kind of fun just to go through some of the more easy difficulty type of problems here. As you can see, I have been able to, let's go ahead and look here at search insert position. So this one is looking to be a little more straightforward. So let's go ahead and try doing the search insert position. So in this one on the left hand side, you can see it's given a sorted array of distinct integers and a target value. Remove the index if the target is found. If not, return the index where it would be found if it were inserted in order. You must write an algorithm with O log n runtime complexity. Okay, so we have our inputs over here on the left-hand side. These are our test cases. So as you can see, nums is defined as a list. Our target that we're looking for is 5. It's returning the index position of 2 because that's where 5 lives. Same list, our target is now 2. It's not in the list, so it automatically goes ahead and spits out 1 because 2, if it were a sorted list, would go right there. Okay, and then down below, we have another list right here, target of 7. It's not in there. So the trick here is the O log of n complexity time. That means that you can't loop over the list more than once. So I'm guessing what you end up having to do here is you have to check if the element that you're currently at is less than or equal to the element that you currently have as your value. If it's the same thing, then you just return that position. But if it is less than your value that you have as the target, and the next value in the list is greater than your value, then you know that this is where the index should be. So this one actually should be pretty straightforward. 4 comma I value in enumerate nums. So we say if value is equal to the target, return I. Elif the value is less than our target and nums sub I plus 1 is greater than, I could just say greater than or equal to the target, then we can return I plus 1. I think we have to check first. Okay. Elif the value is if I is equal to the length of nums minus 1. Okay. If the value is I've already got that check right here, so we don't have to worry about that. We need to check if the value is less than the target, then we return I plus 1. Else, we return, what is the case where you would return, well, I don't think you have to worry about that. It's less than, greater than, so it won't ever be greater than, so I don't have to worry about that one. I plus 1, otherwise return I, and I think we're good. I think that would cover all the cases. Okay, so down below you can see that we have a list here of 1, 3, 5, 6. Our input that we're looking for is number 5. 5 is at the index position of 2. We got the 2 as the output and the expected. Let's go ahead and jump over into our other cases that we could have to be covering as well. So you just go ahead and copy, put this here, 2, and then it's the same list again with 7. So what we're expecting here is 2, 1, and 4. Okay, so we have an accepted answer here. So we have, for our first case, I'm sorry, these are the inputs. So our output would be 2, 1, and 4, as you can see over there, 2, 1, and 4. Let's go ahead and submit this and see what happens. So if it is accepted, then you will see an accepted right here, but this one is not. So our output is none in this case. So here we would just say else return 0. That makes sense actually. And then bada bing, bada boom, and submitted, accepted. We ran here in 67 milliseconds. Our solution was 50.33% faster than all the other submissions, and it was less than 84.69% of Python 3 online submissions as far as memory is concerned. So before we go ahead and close it out, let's go ahead and take one more look here and see if there's any way that we can optimize this. So as per the constraint of the problem, we had to make sure this was O log n. And as you can see, we don't ever iterate over that list more than one time. So we do have a huge advantage there. So the big thing that I can think of, let's go ahead and just talk through some of the logic here. So for I comma value in enumerate nums. So what that's doing is it's unpacking the integer as well as the value at that integer or at that indice. If the value is equal to the target, then just return I. Elif if I is equal to the length of the list minus 1. So we're at the very end of the list. If the value is less than the target, the value or the target would be placed at the very end. So you just return I plus 1. Otherwise, we return 0. Okay, so I think what happens here, we can cut down quite a bit of time if we just check if the 0 solution. So let's also make this an elif. Scoozy. Okay. Make this in our first if. So if I is equal to 0 and value is greater than target, return 0. So we should see this number come down a little bit, maybe closer to maybe the 70-ish percentage, if I had to guess. Yeah, so almost dead on actually. We end up getting a solution that is 69.5% faster than all other submissions. Our memory is right around the same, maybe a little bit less. And then let's go ahead and take one more gander here before we go ahead and close it out. So if the value is less than the target and the index position plus 1 where we're currently at is greater than or equal to the target, then we're going to go ahead and return I plus 1. That makes sense. Elif the value is equal to the target, return I. Elif I is equal to the length of the list, minus 1. If the value is less than the target, then we're just going to put it at the very end. All that makes total sense to me. I'm really, really happy with the solution, so I think that's going to do it for this problem. Let's go ahead and jump over into our next problem. Let's just go ahead and take a look here. Given the head of a sorted linked list, delete all duplicates such that each element appears only once. Return the linked list sorted as well. Okay, I mean that should be pretty easy. All right, so here we're dealing with a linked list. So for those of you that don't know what a linked list is, it's essentially a way for us to tether one element inside of a list structure next to its previous one. So that way we, in programming, we can say like dot next, and then we can go ahead and get all of the values associated with that next value. They're really, really cool in terms of like having really complex data structures. In your day-to-day and work, you don't really use these outside of like dealing with a lot of big data, or maybe even some more object-oriented programming. But for general purpose, we don't really touch these too often. But here's the problem. It says, given the head of a sorted linked list, so that is very, very important, delete all duplicates such that each element only appears once. Return the linked list sorted as well. So that is super important. So we are given the head value, and you can see that we have our solution up here. Well, not a solution, but we have our parent class of list node. So the list node is going to have a value attribute, which is going to be set to what the actual true value is. And then it's going to be a next, which is going to be set as the next list node. And so on and so forth. As long as self.next is not equal to none, then you still are kind of in this realm. But as soon as you get to, let's say 2 in this case, self.next would be none in that case. So it seems pretty straightforward. The way that I'm probably going to end up doing this one would be to look at the value that I currently have and, try and unpack that in some type of a way. Maybe not. And then I could just look at if the next value in the, self.next is not none, and it's also not equal to, if it's equal to the one that we're currently at, then we're going to take self.next of that one and append it to self.next of this one, and so on and so forth. And then eventually we'll get all the way to the end. So you'll see what I mean here, but let's just go ahead and jump right into it. So self head. How do I interact with this freaking thing? Head is equal to that. Self head is equal to this. So while head, you got to be careful here. You got to be very, very careful here. All right. So you want to say current node is equal to self.head. So main reason here is because you do not want to lose track of where you currently are. And so let's go ahead and say while make sure here. Hold on one second. So I'm trying to think here if we actually need to do this or not. I think so. Okay, so while current node dot next, then what we need to do is if current node dot next dot val is equal to current node dot val, then current node dot next equals current node dot next. Okay, so on and so forth. And then eventually you're going to reach an end point. And then you are just going to return. I want to say you would just return head. Could just return head in that point. Let's see what happens. Pretty simple. Judging. Looks like I'm kind of stuck here in this while loop. Okay. So I think I made an assumption. Okay, the number of nodes in the list is 0 to 300. -1 is less than or equal. The list is guaranteed to be sorted in ascending order. Head, delete all duplicates such as only. Return the linked list sorted. Time limit exceeded. Okay. Okay, so I think what I did here was I didn't actually go ahead and update current node equals current node dot next. I never updated the while loop to go on to the next element. So there you go, actually. Yep, that was the problem. Makes total sense, actually. So let's go ahead and grab a couple more test cases before we go ahead and submit it. So we have our first test case of that. Let's see here, run the code. Should be output 1, 2, 3, speeding up. None type object has no dot next. Okay. Dot next equals. Okay, so if current node dot next dot val is equal to the current node dot value, then current node dot next is equal to current node dot next dot next. So while current node, I could just do this, right? Let's see. None type object has no attribute. Hold up. So while current node, I really liked the dot next here. Okay, so while current node, if current node dot next if not current node dot next, I would say that you can probably just break. Otherwise, dot next dot next. Let's just see. These can get really, really hairy sometimes. Okay, we're looking good so far. Is there any more scenarios I can throw at it? I mean, there's got to be, right? Let's go. So it is sorted. So 1, 1 or 2, I guess. 3, 3, 3, 3, 3, 4. Go ahead and see what this does. Wrong answer. Okay, that's what we like to see. Your input, your output will be expecting 1, 2, 3, 4. Confused. Confused why that is. I saw 3. Okay. While current node dot next None. Go ahead and break. Current node.next.val equal to the current node.val. Current node.next. Current node next dot. Current node.next. Maybe I don't need this part. Yeah, let's try this. Ah, got it. Awesome. I was thinking through it there, man. I got really stuck. Couldn't really figure it out. And then I just thought for a minute. And I was like, I think that I'm updating this even when I don't need to. And then that seemed to be the problem. Let's go ahead and submit. I'm feeling pretty good about this one. Got a 36 millisecond success. We have a 98.25% faster than all other submissions online. We have a memory usage of 13.9 megabits. I think less than 73.83% of Python 3 online submissions for removal. So that's going to do it for today's video. As always, if you like the video, please give it a thumbs up. These help out a ton. I think I'm going to be doing a lot more programming videos on the channel. I love to do this stuff. It's what I do for a career every single day. So go ahead and hit that like, comment, subscribe, and I'll catch you in the next one. All right, see you.